Like these things are all not theorems on standard limits. We are going to use it as a formula. Okay. So the first one, that n is being a rational number and a is being a positive integers. Then limit x tends to a, x power n minus a power n by x minus a. Now if you apply a in the place of x, what you will get? 0 by 0. Indeterminate form. So we'll try to factorize it. Okay. So when we try to factorize it, this is a power n minus b power n, that formula. We have expansion for that. So using that expansion, we should expand. So or else we can use that L'Hospital rule. We say it is L'Hopital rule. That means we should differentiate both the numerator and denominator at the same time. Differentiation we came across, right? Did we? No. Now derivate the numerator. The derivative of the numerator is what? N into x power n minus 1 divided by like minus 0, and the denominator derivative is 1 minus a. So we'll be getting limit x tends to a, that n into x power n minus 1. That's all. Now if x is applying a means what we will get? N into a power n minus 1. Okay. So this is for n is being a rational number. What if the sub results? So rational number means if n is a real number also. Real number means like for all the numbers. Okay. So that n is a positive integer, n is a real number. Let me write the results. See, here a is being a positive integer means here a is greater than 0. So and another one, if n is a positive integer and for all a belongs to the real number, n is a positive integer, for all a belongs to the real number, we will be getting the same result. Limit x tends to a, x power n minus a power n by x minus a, that is equal to n into a power n minus 1. Okay. And the second subdivision, that n is a real number and a is greater than 0. So for that case also this result holds. And then this m and m, if m and n are two positive integers, any real numbers. If m and n are any real numbers, any two real numbers, will be having limit x tends to a, x power m minus a power m by x power n minus a power n. Then that will be m by n into a power m minus n. This is the more generalized formula, man. Because in the previous case and all, the value of n is being 1. Okay. But this is the more generalized formula. Alright. And a few more theorems also there. That where is the right side? See, m and n are any two real numbers. Okay, m and n are any two real numbers. Then limit x tends to a, x power m minus a power m divided by x power n minus a power n, that is equal to m by n a power m minus n. Okay, there also the same result applies. Okay, this side color is. Okay, and one more result. Limit x tends to 0 sin x by x is equal to 1. And the second, not the second one, third one, limit x tends to 0, tan x by x is equal to 1. Here also the same reason, you can use L'Hopital rule, differentiate numerator and denominator, you get the answer. Okay. So the note is, like limit x tends to 0, sin ax by x will be equal to a, the coefficient of x. The same way, limit x tends to 0, tan some bx by x is equal to b. Okay, and a few more results are there. The third one, like limit x tends to 0, sin ax minus sin bx by x. Then we can split this, right? So it will be splitted like limit x tends to 0, sin ax by a minus the same limit sin bx by b. So that is a minus b. Okay, and we have few more results also. Like all are easy only, but simply say limit x tends to 0, tan ax by tan bx, that is equal to a by b. Then guess what? What is sin ax by sin bx? A by b. That's all. Okay. And the limit x tends to 0, 1 minus cos x by x. Okay. That also will be equal to 1. So, and few more results, like limit x tends to 0, 1 minus cos x by x square, that is equal to 1 by 2. Why? Because we have that formula, right? 2 sin square x by 2, because of that formula. Also, as a sub result of this, limit x tends to 0, 1 minus cos ax by x square, that is equal to a square by x square. Okay. Sorry, a square by 2. Okay. Also, in a deleted neighborhood of 0, deleted neighborhood of 0 means except 0, all the points will be there. In that place, limit x tends to 0, the step of sin x by x, that is equal to 1. Sorry, 0. Okay. The same way, limit x tends to 0, the step of tan x by x, that is equal to 1. In a deleted neighborhood of 0. Deleted neighborhood means, see, these functions are not defined at the point 0. Except 0, it is defined for all the values. See, here and all, suppose if we say x is not equal to 0 means, that is what this function is defined in the deleted neighborhood of 0, because x is not in there in the domain. Okay. Okay, so let us. Okay. See, so far we have seen like x is approaching to a real number, the overall function will approach to a value. Is it? Now what if the x is approaching to infinity? Or is there any other case where the function will be approaching to the infinity. So that is what these two things. So the first thing is limits at infinity. Limits at infinity means like limit x tends to infinity also possible. This function may attain a limit at infinity. For example, limit x tends to infinity, 1 by x will take. So when x is approaches to infinity, what will come? We'll see 1 by x, right? Like 1 by 10 I will put. 1 by 10 means what? This 0.1. Okay. Now 1 by 100, because x approaching to infinity. X 10 or x 100, that is 0.01. Then 1 by 1000 if I kept means that is 0.001. Like that. As it is going near to x, this x is approaching towards infinity. This f of x will approach where? 0.00000000, infinite number of zeros after that 1. That is where? Near to 0. So limit x tends to the same way tan limit x tends to infinity, tan inverse of x. That is what, when x is approaching to infinity, that is what, pi by 2 will come, right? And the same way, limit x tends to infinity, 1 by x square. That also will go to 0. So these are the values. That means x can be approached to the infinity also. So limits at infinity, when it approaches infinity, what will be the limits? Okay, and infinite limits. Infinite limit means this limit can be infinity. So here x can be approaching to infinity, but infinite limits means this limit can be infinity. Which are all the situations x can be infinity? Sorry, the limit can be infinity. Sine function, tan function. That when x approaches to 0, see, limit x approaches to 0, this function 1 by x, it approaches to where? Now only we have seen infinity. So 0 plus means plus infinity, and it is 0 minus means minus infinity. So the limit does not exist. We have seen in the first class itself, remember. So that is the whole point. The value can approach infinity or the overall limit can be infinity. Also, if both right limit and left limit is infinity, then we can able to say the function is having the limit as infinity. So that is limit x tends to 0, 1 by x square will take. Wait, I'll come. It is a finite value. L is a finite value. Yes, I get it. See, look at this example. Limit x tends to 0. This 1 by x square. 1 by x square means where it will go? If limit x tends to 0 plus right limit is what? Plus infinity only. Now left limit, that is also plus infinity. So we cannot say limit x tends to 0, 1 by x square is equal to infinity. We cannot say. But see, x square, man, positive numbers. When you put minus 0.1, what it is? Minus 10, plus 10, right? We have discussed both case. Shall we discuss again? Like this case. Okay. So now here limit x approaches to 0, 1 by x square approaches to infinity. This like we should not say, because limit is a finite number. Rather, except 0, for all the value a, 1 by x square, it approaches to 1 by a square. So here x is not equal to 0. This conclusion you can give. Okay. You understand what I am saying? See, we cannot say both left limit and right limit is equal to positive infinity, so that limit x tends to 0, 1 by x square is equal to infinity is an invalid statement. We cannot say, because limit is a finite number. But whereas what we can understand from this means, when x approaches 0 only, right? Except 0, many points are there, right? That point is limit x tends to a. That a could be any point, or we can say a is not equal to 0. Okay. So x tends to a, any other point. This 1 by x square tends to 1 by a square, provided that this a should not be equal to 0. Okay. The deleted neighborhood. Okay. Any doubts on this? See, this is different. X can approach to infinity, but L is a finite number only. This side, what I said, both positive and negative, we get infinity. It is possible to have a limit as infinity, like I said. Like the one-sided limit may approach to, but we cannot say the overall function limit is infinity, because limit is a what? Limit is what? A finite quantity. So here also we checked left limit, right limit, but here both came to infinity. So what we decided, what we have discussed previously, if both are same number, overall limit also goes to infinity, like we may think, but that like we should not say. Which one? This one. Limit does not exist, yes. See, limit x tends to 0, 1 by x, the limit does not exist. We solved this question, man. LHL not equal to RHL. This kind of situations also may come. We came out, we took this kind of output from this, right? Like the domain can be modified like that. Okay. Alright. And then some more standard limits. So where is everything? See the first one, limit x tends to 0, e power x minus 1 by x, that is equal to 1. In the same way, limit x tends to 0, a power x minus 1 by x is equal to log to the base e a. Both are same result only. But in place of a, if you substitute e, means log e to the base e, all e is 1. Okay. And the other one, limit x tends to 0, 1 plus x whole power 1 by x. Yes, that value is approaching to e. And limit x tends to infinity, 1 plus 1 by x whole power x, that is also e. And limit x tends to minus infinity, 1 plus 1 by x whole power x, that is also. See, these are all formulas, man. That's all. Indeterminate form. So there are 7 indeterminate forms are there. The very first and foremost things we know is like 0 by 0 and infinity minus infinity. No, not x by 0. That is not defined. We are talking about indeterminate form. And 0 power 0 and 1 power infinity and 0 power 0, 1 power infinity, infinity power 0, zero into infinity. You might get some doubts here. Indeterminate form means we cannot evaluate these things. We cannot find the answers for this. 0 by 0, okay, we are seeing. But infinity minus infinity should be 0 only, right? Then why we are saying indeterminate forms? Suppose we put x minus x means it will become 0. Then why infinity minus infinity? Because the quantity, the infinity is an unknown quantity. Okay. When this like one situation arises means this can be somewhere near, or this may be, the other things may be somewhere away from this point. Okay, you get what I am saying? Suppose this approaches to like f of x minus g of x means, wait, f of x minus g of x means f of x approaches to 2, y of x approaches to 3 means we can substitute and write it. Okay, they are different points, but infinity means we don't know what it is. It's way beyond that, right? So this infinity is whether it is 2 or 3, like near to this infinity or not, we don't know. So who reaches first, the exact value we don't know. That is why this is indeterminate form. Like the 0 power 0. What sir? Anything power 0, it is 1. Is it or not? Then why 0 power 0 is indeterminate form? That is also should be equal to 1, right? Why unknown? Because here also 0 power some f of x will take. Okay. No. Like f of x power g of x will take. F of x power g of x. So suppose f of x is approaching to 0 for some x approaches to some value k1, let us say, and g of x maybe approaches to 0 for x approaches to some k2. They are not the same numbers, but based on the behavior of the function, which one will become 0 first we don't know. Is it or not? If this becomes 0, first 0 means overall value is 0. Whereas if that becomes first 0 means overall value will be 1. But we don't know their nature. 0 power 0, we don't know. We cannot estimate. That is why it is indeterminate form. The same reason for this 1 into infinity also. So 1 power infinity also. Infinity power 0. Same scenario. But 0 into infinity. Why 0 into infinity? Definitely that should be 0, right? 0 into any number should be 0. But this is also in such a case that some f of x into g of x, this may be like before itself it will become 0, this may be approaching to infinity later, or this may be approaching to infinity, this may be approaching to 0, but when it will approach that we don't know. So that is also indeterminate forms. Okay. Alright, any doubts on this? This indeterminate forms, limits at infinity, infinite limits. Okay. Now evaluation of limits. The first one, direct substitutions. We have seen this method, right? Like directly we'll substitute and we'll get the limits. That's all. Suppose if direct substitutions fails, then we go for factorization. If factorization is also not possible, then we'll go for rationalization. If rationalization also not possible, then we'll go for using identities or using standard limits. What are the standard limits? We have seen, right, this kind of formulas, that formula structures, those things. Okay. Like for each method, we will see one example. So erase everything. Direct substitution method. It's very easy, very easy. Like limit extends to 0 or some 2 will take this 2x square plus 5x plus 7. What is the value? We will directly substitute 2. Wait man, what you are saying? 2 into 2 square, 5 into 2 plus 7. So that is 8 plus 10 plus 7 will get 25 as the answer. This is a direct substitution. Suppose this direct substitution is not possible, then we comes up with the factorization method. For example, limit x tends to 3, x cube minus 27 by x minus 3. How to calculate this? We'll factorize. Factorize, man. How to factorize? This is a cube minus b cube formula. A minus b into x a plus ab plus. So this is what actually limit x tends to 3. This is x cube minus 3 cube by x minus 3. Okay. Then using that you can expand. That is limit x tends to 3. This is x minus 3 into x square plus 3x plus 9 divided by x minus 3. X minus 3 out. Then there we can substitute 3. So that is 9 plus 9 plus 9. 27 is the answer. Okay. Or using standard limits. Rationalization, I'll say it. Like I thought this can be evaluated using the standard limit x power m by a power n. But this limit extends to what? Yes, using standard limits only. Wait, this question I'll say and then we'll go to that rationalization. See, limit x tends to a, x power m minus a power m by x power n by a power n. We have seen this result, right? Yes, m by n, a power n minus 1. So here in this situation, the m value is 3. Okay, and the n value is 1. A value is 3 again. So m by n, that is 3 by 1 into 3 power 3 minus 1. So we'll have 3 into 3 square. 27 is the answer. How fast you got the answer? Here I factorized, cancelled, substituted, I got the answer as 27. Now using standard limits, immediately. That is the, all we have to do is, we should identify which identity is possible, like that. Okay. And then rationalization. Rationalization, root of 1 plus x minus 1 by x. Okay. Shall I erase this? say limit x tends to 0 root of 1 plus x minus 1 by x. Now if you apply limit directly, you will be getting 0 by 0 in indeterminate form. And if you apply factorization method, we cannot factorize this. Or if you apply standard limits, not standard limits, sorry, rationalization. Yes, rationalization is possible. How we can rationalize this? Limit x tends to 0 root of 1 plus x. So the numerator should be rationalized. So this is root of 1 plus x plus 1 by this is root of 1 plus x plus 1. Okay, this numerator in the form of a minus b into a plus b. Then we'll get what? Limit x tends to 0. This root of 1 plus x whole square minus 1 square by x into root of 1 plus x plus 1. Then square this. Limit x tends to 0. This is 1 plus x minus 1 by x into root of 1 plus x plus 1. Then plus 1 minus 1 gets cancelled. Remaining x1 will be there. That x, this x gets cancelled. If you apply limit x tends to 0, we will get 1 by 2 as the answer. That means 1 by root 1 plus 1, 1 by 2 is the answer. Okay. Or there are some other ways also. Say using standard limits. How we can solve this using standard limits? Limit x tends to 0. Wait man, limit x tends to 0. And this 1 plus x power 1 by 2 minus 1 power 1 by 2. And then, see, this is resembling that formula limit x tends to a, x power n minus a power n by x minus a. Try to obtain this. So instead of x, we have 1 plus x. So denominator x is there, right? I am putting plus 1 minus 1. Possible in the denominator itself. Plus 1 minus 1. Then this is 1 plus x minus 1. Shall I say? Okay. And we should fix this limit. How we can fix this limit? Now it is exactly matching this formula format. How we can fix this limit? When x approaches to 0, 1 plus x approaches where? 1. Is it or not? X is approaching to 0, then 1 plus x approaching to 1 plus 0, that is 1. So in this limit also we can change. X approaches 0, that implies 1 plus x approaches 1. Now you see x approaches a, x is 1 plus x, a is 1. So x power n, power 1 by 2, this 1 by 2. Okay. Alright, a value is 1. So x minus a. Now what is the formula result? N into a power n minus 1. So what is n value here? 1 by 2. A is 1. Power n minus 1. That is again 1 by 2 minus 1. Okay. For these kind of situations only we have seen that n is a natural number. N is a rational number. Remember, n is a rational number and 1 is, the a is the positive integer, like that. Okay. So this is what 1 by 2 into 1, we get 1 by 2 as this. Now this case, which is easy, whether this converting into standard limits is easy or the rationalization is easy. Rationalization only easy. This requires lot of efforts to convert. There we can simply rationalize and substitute easily. Though the steps are more, that would be easy. Okay. So these are all the methods to evaluate a limit, like direct substitution, factorization, rationalization, standard limits, everything. Okay. You have any doubts in this? Okay. Perfect. Alright, now this exercise 2.2 we can see. Shall I erase everything? The question number 1. Limit x tends to a x square minus a square by x minus a. What formula this is? Now only we have seen what it is. Limit x tends to a x power n minus a power n by x minus a. So n into a power n minus 1. So our answer is, here n is 2, a is a only. So 2 into a power 2 minus 1. 2a is the answer. That is it. Any doubts in this? Second one, limit x tends to 2, x minus 2 by x cube by 8. This also you can use the standard limits. How? See, limit x tends to 2, 1 by x cube minus 2 cube, that means by, this is what, x minus 2. Yes, that formula. So numerator limit x tends to 2, 1 by denominator limit x tends to 2, this x cube minus 2 cube by x minus 2. So what is that formula, remember? Limit x tends to a, x power m minus a power m by x power n minus a power n, that is equal to m by n a power m minus n. The denominator alone we can apply that. So numerator 1 only, denominator 3 by 2, a is 2 power 3 minus 2. Okay. So answer is 1 by 3. Okay. Any doubts in this? Is the answer correct? Okay. Now the same way. Hey, wait. You don't need to split this like this, man. Because m is greater than n, m less than n, like that. Well, we haven't seen any things. Directly m value 1, n value 3, like you can substitute. See, this is 1 by 3 into a is what? 2 power 1 minus 3 will come. Is it? Is it? Have you checked the answer? The answer is correct. Answer 1 by 24, is it? Yes. 1 by 12. Then why here answer is not coming? I kept 3 minus 2. Sorry. It is 3 minus 1. Too bad. 1 by 3 into 4. Then that can be simplified. 1 by 12. This much energy not needed. You don't need to waste. See, 1 by 3 into 2 power 1 minus 3. That is what? 1 by 3 into 2 power minus 2. Here itself we will get 1 by 12 as the answer. Okay. Now next one. This and all you can say the answer by simply looking into it. Limit x tends to 1, x cube minus 1 by x power 4 minus 1. Answer is what? 3 by 4 into 1 power 3 minus 4. So answer is 3 by 4. That is it. And next one. Limit t tends to 8, then cube root of t minus 2 by t square minus 64. See, look at here. This is limit x tends to, shall I erase that side? See here, limit t tends to 8 cube root of t minus 2 by t square minus 64. Now if you apply directly, cube root of t means 8, cube root of 8 means 2, 2 minus 2 0. Here also 8 square, 64 minus 64 0. So rationalization possible. We'll try to rationalize it. But standard limits also we can use. So limit t tends to 8. This is t power 1 by 3 minus 8 power 1 by 3. Why 8 power 1 by 3? That is cube root of 8. Cube root of 8 is 2. Like that, this is t square minus 64 means that is 8 power 2. Okay. That n can be a real number also, is it? A is a positive integer. That situation. Now here t tends to 8, that formula. Then we'll get what? 1 by 3 by 2 into 8 power 1 by 3 minus 2. Right? M by n into a power m minus n. Okay. So this is 1 by 6, 8 power minus 5 by 3. 5 by 3 means, see, look at this. This is 1 power 6 into 1 by 8 power 5 by 3. Is it? So 8 power 5 by 3 means what it is? That is 8 power 1 by 3 whole power 5. Is it? 8 power 1 by 3 how much? 2. 2 power 5. 2 power 5 is 32. 1 by 6 into 32. 6 3s are 18, 192. Okay. Is that the answer? Have you checked the answer? Yes, 1 by 192. What happened? Ordering lunch? No, ordering dinner. No. Okay, any doubts in this? Okay, now look at the second question. What second, fourth? For second subdivision and fourth subdivision are asking. Second question, fourth subdivision. Is it? Okay, we'll work out. Wait. See the second question. What does that mean? You see the second question, what you are thinking? Yes, man. Find the limits, man. How to find the limit? Are we finding Ilakana Kuripu here? Second question, first subdivision. Yes, factorize. Why factorize? See, always we should. No, it is not like that. Because always we try substituting the value. Okay. That is 2x square plus x minus 3. So you substitute the limit directly. 1 if you substitute means numerator will become 0, denominator also will become 0, 0 by 0. So direct substitution fails. And then factorization. Factorization, numerator already in the factor. Denominator we should factorize. How we can factorize? 2 into minus 3, that is minus 6. By multiplication minus 6, addition 1, we should find such numbers. So that is 2 3s are. 2 3s are means that addition gets positive, small number gets negative. Then we'll get this 2x square minus 2x plus 3x minus 3. Now we can take 2x as common. Then here x minus 1. Here 3 as common. Then x minus 1. Then we'll get 2x plus 3 into x minus 1 is a factor. So limit x tends to 1. 2x minus 1 into root x minus 1 divided by, this is 2x plus 3 into x minus 1. Okay. Now this x minus 1, root x minus 1, shall we cancel? No, we can't. What formula? No. Standard limit formula. That is also we can do. That also we can use. Then limit x tends to 1. This is x power 1 by 2 minus 1 power 1 by 2 by x minus 1. Okay. Then here x approaches 1 means 2 minus 1 divided by 2 plus 3 into there it is 1 by 2 into 1 power 1 by 2. Is it? Wait. One power 1 by 2 minus 1. Yes. Now it is correct. And then simplify. We'll get 1 by 10 as the answer, right? 2 minus 1, 1. Here 1 by 2, 2 plus 3, 5. 1 by 10 is the answer. Alright. Any doubts on this? Okay, now look into this one. Second subdivision. Limit x tends to 3, x cube minus 6x minus 9 by x power 4 minus 81. How to solve this? No. Cubic polynomial we can factorize, man. So this x power 4 minus 81 will take. This is nothing but x power 4 minus 3 power 4. Is it? 3 power 4 81. See why I am saying taking the denominator first means because of these factors we may identify these factors. Okay. And this is what? This is nothing but x square whole square minus 3 square whole square. Is it? Now this is looks like a plus b whole square formula. Then x square plus 3 is a factor, x square minus 3 is a factor. Then that can be again factorized. Yes. Then that can be again factorized. That x square not x plus 3 into x minus 3. Okay. So among this any one is a factor of this. The numerator is x cube minus 6x minus 9. We don't know their factors. You remember the method to factorize a cubic polynomial. One factor we should assume. So obviously, undoubtedly, x minus 3 is a factor. Why? Because x approaches 3. When you substitute 3 only, it will become 0. That is why I took this decision of factorization. Is it? Suppose when we substitute 3, 0 is not coming, means we are not supposed to do this. Simply we will put infinity, the limit does not exist, like we said. Okay. No. That also we can do. Or we can, or we can assume this another quadratic factor it might have. That is something, all the leading coefficient is 1. So some x square. The last number is minus 9 should come. So some ax and then minus 9 should come means here some plus 3 should be there. This a alone we should find. There is a quadratic factor. Now simply multiply them. Then it is x cube plus ax square plus 3x minus 3x square minus 3ax minus 9. Now we can equate the coefficients. Equating the coefficients of x square. Here x square coefficient is 0. Here x square coefficient is a minus 3. Then we'll get a is equal to 3. So we got our factor easily. That was too fast. So I'll explain once again. See, we are supposed to factorize, man. For factorizing, traditionally what we will do, we'll substitute one value, it becomes 0. Based on that, we'll divide. Like when we divide means what it is? This is x cube minus 6x minus 9, right? This is divisible by x minus 3. The quotient we should find. Now divide. The division method I am explaining. When we divide means we have x square over there and here inside x cube is there. That means what? Wait, I will say it is not a formula. So here x cube. Then what must be multiplied with x in order to get the x cube? X square we should multiply. That x square should be multiplied with this 2. So we will get x cube minus 3x square. Alright. And then put alternate signs, minus plus, that means we are subtracting. These two things gets cancelled. So remaining 3x square minus 6x minus 9. Okay. Because they are not like terms, we cannot add or subtract them. We can simply put plus or minus in between them. Okay. Now here 3x square is there. Here only x is there. Then what should be multiplied with x to get 3x square? 3x. So 3x means what? 3x square. 3x should be multiplied with both of this. So 3x square minus 9x. Now alternate signs, minus plus, as we are subtracting. This 3x square, the 3x square gets cancelled. 6x, minus 6x plus 9x. That is 3x again and minus 9. Okay. Now here x is there, here 3x is there. Plus 3 or minus 3? Plus 3. So we will get 3x minus 9, answer 0. That is the quotient. But this method is, I am just assuming, what assuming? X minus 3 is already a factor. Because we substituted, we got 0. The another quadratic factor will be there because it is a cubic polynomial. Another quadratic factor will be there. So some x square should be there. All the leading coefficient of x is what? 1 only. So here also 1. Plus some x coefficient will be there, some ax. Plus 3. Why plus 3? Because this constant term is minus 9. To match this, here minus 3 is there. What should be multiplied with minus 3 to get minus 9? Plus 3. And then I multiplied again, I equated the coefficients. Either way we can do. Okay. So now this one, limit extends to 3. The factors are x minus 3 into x square plus 3x plus 3 whole divided by this factors x square plus 9 into x minus 3 into x plus 3. So x minus 3, the problematic guy eliminated, and then remaining things you can substitute peacefully. Then 3 square 9 plus 3 by this is 9 plus 9 and this is 3 plus 3. So we'll get 18 plus 3, 21. 21 by 18 into 6. So 18 into 6 now, that is 6 3s are 18, 7 3s are 21, 7 by 36 is the answer. Okay. Any doubts on this? Perfect. So the same way, all the other questions also can be solved. That modulus of x square minus 9 is there, right? We consider that value as being positive. X plus 3, because that is inside the root, right? So erase everything. See, limit x tends to 3, x minus 3 by square root of mod of x square minus 9. So, mod of x square minus 9, x is approaching to 3. So left limit, right limit we should calculate. What is left limit, right limit? RHL. Limit x tends to 3 plus, that is x minus 3 by, this will be positive, right? Square root of x minus 3 into x plus 3, because that will be fully positive. X square plus 9 only will be there, this like, and we can substitute x tends to 3 plus, this is x minus 3 into root of x minus 3 into root of x plus 3. These things can be simplified. Then at last we will get limit x tends to 3 plus root of, what's that? See, mod x means positive x if x is greater than 0, negative x if x is less than 0. Then modulus of x square minus 9 means positive x square minus 9 if x square minus 9 is greater than 0, minus of x square minus 9 if x square minus 9 is less than 0. That means it is positive x square minus 9 when x is greater than 3, minus of x square minus 9 when x is less than 3. Okay, that is why 3 plus 3 minus we are calculating. 3 plus is 0, because 3 plus means we will be getting this answer inside the square root. Okay, 3 minus means, wait, 3 minus we will check. Shall I erase this? Say limit x tends to 3 minus, then x minus 3 divided by square root, inside square root. For this modulus what we will get? 9 minus x square will get, because minus of x square minus 9, right? So 9 minus x square means this is limit x tends to 3 minus x minus 3 by square root of 3 minus x into square root of 3 plus x. Still it is possible. Limit x tends to 3 minus, here that is minus of 3 minus x we can write, is it? We will take minus as common from this. Then square root of 3 minus x, so square root of 3 minus x divided by square root of 3 minus x into square root of 3 plus x. These two things gets cancelled. Again if you apply 3 minus means, 3 if you substitute means we will get 0. So the answer is 0. Limit exists. Okay, any doubts on this? Okay, so I think that's enough for the day. We have seen standard limits, infinite limits, and limits at infinity, and indeterminate forms, and this exercise. Still few more questions are there, like rationalization part is there, and one more question is there. After completing that, we'll go to the next exercise. Okay, that we can see tomorrow. Okay, then that is it. Do you have any doubts? Okay, then I see you tomorrow. Take care. Bye bye.